Hello friends, welcome to follow up. Let's have a look at problem 654, maximum binary tree. In this video, we're going to explain a recursion solution. So actually this problem is rather straightforward. So basically the main statement tells us how to approach this problem in coding. Here we are given an integer array called nums with no duplicates. This is an important assumption, right? So a maximum binary tree can be built recursively from nums using the following algorithm. First, create a root node whose value is the maximum value in nums. So due to the assumption that the elements in nums are unique, and therefore we just have one element corresponding to the maximum value, right? So this actually eliminates ambiguity. Secondly, we recursively build the left subtree on the subarray prefixed to the left of the maximum value, right? Similarly, we do this for the right subtree. So we are required to return the maximum binary tree built from nums. So here are two examples. So example 2 is very special because here the nums list is in a strictly decreasing fashion, and therefore so the root will be the first element, and then if you continue, so they only have a right subtree, and the right subtree will be the element, the second one and third one, and so on. So this is the tree format. And the first example roughly is the generic case. So here we have a 6, so this will be the root, and then we have 3, 2, 1. So this 3, 2, 1 actually is part of example 2, right? So we can in all we can see reversed. Example 2 is part of example 1. So this is the tree in example 2. And then we have 0 and 5 because 5 is larger, so 5 will be serve as the root of the right subtree of 6, and then 0 will be the left child of 5. So this will be the so-called maximum binary tree. So here maximum means that the root always have the maximum value, right? If you look at it globally or look at it locally, right? So with that said, let's also look at the constraints. So basically in the leetcode problems, the constraints are additional assumptions. Sometimes this constraint reveal important information as on what algorithm we should use and what term complexities we need to use, right? So here the length of this list nums is bounded above by 1000, so which is not a very large number. So the elements are non-negative and bounded above by 1000, and all integers in nums are unique. So in this problem, overall, it emphasizes that the node values are unique. So basically, if unique, so we can find the maximum element, and then we can find its index. Then to the left of this that index, we're going to build left subtree, and to the right of that index, we're going to build the right subtree. So basically, this is also the big picture of the coding part. So here, let me write some small summaries, right? So here we are going to use recursion, right? So the reason we use recursion largely due to, if you think of trees itself is a recursive abstract data type. Meanwhile, here the algorithm itself is also in a recursive format. So roughly we just need to translate these 3 items into coding format. So here we're going to present 2 formats of coding. So essentially they are the same, but depends on our preference. So first I'm going to I'm going to treat a special case. So if not nums, So in this case, we just need to return or return null if you like. So this case forms the base case. Otherwise, so we can find the largest element, right? So the largest element, let's call it largest. The largest, we can use the max, right? So because in this case, after the if check, nums is not empty, so we can always use this function without assuming a default value, right? And then we can get the index, right? So that is nums index largest. Then we want to build the left subtree and the right subtree. So for this purpose, let's use two lists to represent the left part of the array and the right part of the array relevant to this index, right? So here I'm going to discuss if idx is greater than 0, because if it's 0, we just use left as empty, right? So if it's greater than 0, so we're going to set left to be nums, so up to but not included index, right? So that's the one. And also we need to check the idx. So if it's the last element, so if it's the last element, so we're going to keep right to be empty, right? So we want to check if idx plus 1 is less or equal than m minus 1. So this is the largest index, right? So if not, so we're going to set right to be nums idx plus 1. So because in this case, this idx plus 1 will not have index out of range problem. And then what we're going to do is we set the root to be a tree node instance or object. So value will be the largest, right? Then we can set its left child. So then we are going to call this function itself, but on left, right? And then also we are going to do the same thing for right. So we're going to call construct. So this will be the right. So this way we finished constructing or building the maximal binary search tree, not binary search tree, in a recursive format. Now we are ready to return the root value. So this is a solution format, but in this format we are doing recursive call for the function for the method itself, right? So now let's look at the test. N is not defined, so let's see, name n. So here let's write length nums. Yeah, it passes one example. So now let's look at the generic case. Yeah, it passes all the generic cases. So if you prefer not calling the method itself, you can write an inner function. Let me copy this code, and I'm going to rename this one as version v1. So what I'm going to do is to change this one to be a inner function. So let's call this build. So it's going to accept a nums. So here nums is just an argument name. You can change to be other names. So here I'm going to shift this one tab. So here I just need to call this build, right? And call this build. And then what we're going to do is that just do the function call and do the return build, so nums. So here the nums is nothing but this one, that is the one to the supplied to the function signature here. So now let's do a check. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the generic cases. So I guess with this done, that's about it for this specific problem and this video. So lastly, maybe one last word is that when we look at the problems related to tree. So sometimes it's good to think of recursion because the tree is a recursive abstract data type, and but also, just for practice purpose, you can also use iterative format to digest the detail if you like. So that's it. Thanks.